How's it going, everyone? It's Chow here, and today we are going to briefly discuss rain shadows. So let's get started. Okay, so rain shadows are very fascinating because they're kind of microclimates that are slightly different than what's expected in terms of the overall climate based on perhaps latitude. So prevailing winds, our friend, the prevailing winds from the oceans can actually cause precipitation. So if the prevailing winds from the oceans are traveling towards the land and it hits a mountain range or some extremely tall hill or something like that, most likely a mountain range since mountain ranges are tall enough to do this, it's going to force the air upwards. So the prevailing winds travel towards the coast, it hits a mountain range, and the air is forced to move upwards. When the air moves upwards, it cools and it condenses. But what's really interesting here is that when it cools and condenses on the face of the mountain facing the ocean. And when that happens, those clouds are going to form on the side of the mountain facing the ocean. And those clouds then are going to ultimately condense. Cooler air can't hold moisture as well, and it's going to precipitate. And so it's going to come down as either rain or snow, some kind of precipitation. And so what actually occurs then is that the cooler, dried air now, so the air lost all of its moisture over here on this side, facing the water, facing the ocean, that cool, dry air is going to continue moving up over the mountain towards the other side. But this air over here that's moving towards the other side is now completely devoid of water. So this region over here on the opposite side, it's going to actually be much drier. And so this is very fascinating because it's in the same general location in terms of latitude, but you can have extremely varied microclimates on just a short amount of distance. And so quite phenomenally, you have different biomes on the two sides of the mountain. On the side facing the water, facing the ocean, where there's lots of precipitation, you might have very lush forests with lots of trees. On the other side, where the cool, dry air is now passing through and doesn't have any moisture, it's going to be extremely arid, and you might have a desert on the other side. So what's really fascinating about rain shadows is that it leads to varying distributions of climate patterns, and as a result, it leads to different biomes, which ultimately can lead to variations in organisms as well. And so this varying distribution of climate patterns across a small range is quite fascinating because oftentimes you can't predict that just by looking at a map. Because looking at a map, the latitude of this region and this region might be exactly the same. But because of variations of the land, these cause variations in, for instance, in this case, precipitation patterns, and that as a result can cause variations in distributions of microclimates. And so we can see this in real life in places like Washington, where on the western side that's facing the ocean, you have high amounts of moisture from that uplift of air caused by the Cascade Mountains. So the high moisture prevailing winds are coming from the west to the east, and the air is going to be pushed up some kind of a blockade, in this case a mountain range, the Cascades. The air rises and cools. The cooler air precipitates all over this western portion of the state of Washington, and then the dry air moves over to this plateau over here, and as a result, you can see a dramatic difference in the microclimates. On the western side that's facing the ocean, you have high amounts of lush vegetation, almost a temperate rainforest type of habitat. Whereas on the other side, it's extremely dry because that cool, dry air has moved over and now it doesn't have any moisture. And so on the opposite side here in the east, you can have almost an arid, sagebrush-looking steppe that's almost desert-like. So you might not expect dry conditions given this location here in Washington, but due to local changes in microclimate, in this case a topographical feature like a mountain range that's blocking the way, there is a difference. And so you can see this here in Washington, And you can also see it in other places like California, where the Sierra Nevadas does something different. And on the western side here, that's facing the ocean, you have warm air that's forced up and high amounts of precipitation, great lush forests, including species like sequoia trees and many different pines and conifers. But on the opposite side, it's one of the driest locations and one of the hottest locations. That's actually Death Valley over here. So you have a desert on this side that's facing away from the ocean, and this side over here that's extremely lush and forested facing the ocean. And this variation, again, is not due to location or latitude, but due to some kind of a topographical feature that causes variations in microclimate. In this case, that topographical feature causes variations in precipitation levels, which ultimately leads to variations in the biomes available as well. So this is a sort of a rundown of the rain shadow effect. I hope you found it useful. Best of luck studying, and I'll see you in the next video. Take care.